And welcome back, AP Calc students. Time for another FRQ. So, today we're going to be looking at the year 2013, number 2, off of an old AP Calc AB exam. So let's take a look and see what they want to know. The question is a number 2, hence it's a calculator question, and that may make a few of our calculations a little more difficult. But let's see what they want to know first. So the question says, a particle moves along a straight line for 0 less than or equal to t less than or equal to 5. The velocity of the particle is given by v of t is equal to -2 plus the quantity t squared plus 3t to the 6/5 minus t cubed. And the position of the particle is given by s of t. It is known that s of 0 is equal to 10. Well, this kind of question falls under the category of PVA, position, velocity, acceleration. Now, position, velocity, acceleration are very common in physics and calculus, and one of the reasons they're so popular in calculus is that if you're given a velocity function, this allows them to ask you questions that require deriving and integrating. If you derive, you go from position to acceleration by deriving, and if you're given acceleration, you go back to position by integrating. So this is a very common type of question that is asked. So they give us the velocity function, not surprising, and we're probably going to have to do both integrating and deriving to get some information. So they do give us a pretty ugly velocity function. It's raised a quantity, a quadratic that is raised to the 6/5 power and then minus a cubic. So pretty messy. And we're going to want to take advantage of our calculator for some of these calculations. And but let's see what they want to know. We have a unit of 5. We could call them seconds. They don't denote them. They do say that our particle is given by s of t, so we can be pretty confident it's a vertical motion. If it was horizontal, it would be x of t. And we have an initial position, s of 0 equaling 10. So let's see what they want to know. Let's see what we can figure out. So part A says, find all the values of t in the interval from just 2 to 4, for which the speed of the particle is 2. Well, the first thing they're going to quiz you on here is, do you know what speed is? Well, by definition, speed is equal to the absolute value of velocity. So that equation is quite important. So if we take just the velocity function and set it equal to 2, we're going to miss out on a value because it's the absolute value. So we want to make sure you have this memorized. So it looks like what we're going to want to do is take the given function, which is -2, plus the quantity t squared plus 3t raised to the 6/5 minus t cubed, and we're going to take the absolute value of that, and we're going to see when is that equal to 2. That's the question, and that's over the interval from 2 to 4. Well, this is solvable. Be pretty ugly, but you could do this, and it's a calculator question, so we're going to take advantage of our calculator and see when this is true. The best approach to do this would be to graph this function, and then also graph this function. It's really a constant, and we'll see where they intersect. So we'll go to our calculator, and hopefully we can get this out of a glare. So I'm going to enter the first equation, being the absolute value of the velocity, but I'm going to go to my math menu and go over here and grab absolute value, which is the first one under the number tab. So there's the absolute value, and I'm going to put in -2 plus the quantity t squared, which our variable is x in this context, plus 3t, and then we're going to raise that to the 6/5 power, and then we have minus x cubed, or t cubed. So there is that function. And then the question is, when does that function equal 2? So if we can just see where these two things intersect, we'll be in good shape. So I'm going to go to Z6 here, and we'll see what happens. Taking a while to think through, we got this function that you can see. It seems like it's bouncing on the x-axis, which makes sense because it's absolute value. And then also, it looks like we have the function coming across just y equals 2. So the question is, when do those two functions equal each other, cross each other? But the question says they only want to know this in the interval 2 to 4. And the overall interval for the question is 0 to 5. So I'm going to zoom in on this quite a bit. I'm going to change my window to be a little easier to see. And I'm going to say, well, my x minimum is just 0, and my x maximum is 5. And my y minimum, this is an absolute value question, so there's no negative y value. So I'm actually just going to make it -1 for perspective here. And now let's graph that again. And we'll be zoomed in kind of nicely here. And you can see there it's bouncing between 0 and 1. And this, the x-axis here, there's 1, 2, 3, 4, and 5. So it's just asking us for finding the x-intercepts in this little interval right here from 2 to 4. And you can see it looks like we've got 2 spots right here where they intersect. And if we use our calculate function and we say, where does it intersect? First curve, second curve, and then we'll toggle over here, and I want to know this value. And according to our work here, is 3.128. That's one of the values. And the second value, just for the, we would do the same thing on the other side, and we would get 3.473. So it looks like these are the 2 times where the speed is equal to 2, but we had to do this by setting absolute value. Now you could probably see if we didn't account for the absolute value, we never would have gotten this first value, because the function would be underneath the x-axis. We would have only gotten the second. So the most common error is not accounting for the absolute value. So that's a pretty simple question. If you know what speed is and you know how to use your calculator, there it is, and you've got your 2 values rounded to 3 decimal places. Now if the function was a little easier, and this was a non-calculator question, we would have done the same thing, but absolute value, we would have had the positive and the negative version of the equation and set it equal to 2. And that approach would work well, but obviously not with this messy of a function. So let's move on to part B. Part B says, write an expression involving an integral that gives the position s of t. Use this expression to find the position of the particle at time t equals 5. Well, I'm actually going to do the second part of B before I do the first part. I think it'll be a little easier. And if you look back here at our little expression here, PVA, they're asking about the position, and they're asking about it at time equals 5. So we have velocity. So it looks like if we just integrate velocity, we'll be able to get position. But you got to keep straight the fundamental theorem and how that affects your A and B value. So what I'm going to do is I'm going to set this up, and I'm going to integrate over the entire interval from 0 to 5, and I'm going to integrate the velocity to get the position. So if I integrate velocity, the integral of velocity is equal to position, and so they don't use a p, they use an s. That's sometimes confusing, but it's going to be s of 5 minus s of 0 using the fundamental theorem. Now just to clarify, to make sure you're not confused here, if you think back to earlier in the year, I'll write this briefly here. If you remember, if you're integrating from a to b of a derivative, the integral of a derivative is the original function evaluated, f of b minus f of a. So this is just the fundamental theorem right here. But for us, we know that velocity is the derivative of position, just like we know f prime is the derivative of f. So that's why the integral of v is equal to s. The integral of v is equal to position, or s. S is the variable that gets used here. So this expression right here is directly connected to the way we did this earlier in the year. But the question is asking, it says find the position at 5. So what it wants is it actually just wants that value. So that means actually we take this value and we add it to the other side. And so you would say, well, s of 0, and another name for s of 0 is the initial position, plus the integral from 0 to 5 of v of t dt is equal to the position at 5. And this is what we're asking for. Well, it just so happens in the question they tell us early on, they say it is known that s of 0 is equal to 10. The initial position is 10. They never give us information we don't need. And so I have 10 plus the integral, 0 to 5 of v of t, and that will give us our answer. Well, this integral is going to be a part of the calculator. So I'm going to go to here, and I'm going to go to my math menu, take advantage of my integral and I'm just going to put in these numbers. So I'm going to integrate from 0 to 5, and then I'm just going to enter the velocity function, which is this mess up here. So I've got -2 plus left parentheses, again, t squared, and we've got plus 3t. Those parentheses, raise that to the 6 divided by 5, and then we have minus x cubed. My variable of integration here is x or t, and let's see what we get. The calculator do the work. We get negative 19.207 rounded. So this is 10 minus 19.207 rounded, which is going to equal negative 9.207. So that's going to be our position right here. Now the earlier part of the question says write an expression involving an integral that gives the position t. Well, all I want to do is, I think this is easier to follow when we do with the numbers. What they want you to do is now write this for just in general terms. And so I'm just going to replace my 5 with a t value for any particular t value. So I would say, well, in that case, if I just integrated from 0 to t, a velocity function. Now, if this hasn't been stressed to you, you want to remember that if your interval has a variable, the integral variable has to be different. It does not make mathematical sense for those to be the same. So the integral from 0 to t of v of x dx is equal to s of t minus s of 0. And so what they wanted to know is write an integral expression for s of t. Well, I'm just going to add this over. So here's what they were looking for. S of t is equal to the initial position s of 0 plus the integral from 0 to t of the velocity function. And this actually was the first part of the question. And then if you think about it, I used this to figure out what was s of 5. So there's definitely a connection here between this question and this one right here. But I think it's easier to follow it, actually do the one we're looking for first, and then show that we could use it for all cases. So that is B. All right, let's keep going. Letter C says, find all the times t in the interval 0 to 5 in which the particle changes direction. Well, changes direction, if you want to think about it this way, changing direction is the same as asking what your maxes or minimums would be. So if this is a position function, and we know we have vertical motion here, you want to think about it like this. This is what our particle is doing. So it changes direction when it gets to a maximum or a minimum. So these would correspond to critical numbers that would give us our maxes and mins. This is what we're looking for. When does it change direction? So this is an example of where in the AP you just got to figure out their lingo. So when they say find where the particle changes direction, that's code for find your critical numbers and then test your interval and see if you can find that. So this is what actually we're doing. Now this was just a random example sketch here. This does not represent the function we have. I was just showing that for an idea. So if we need to find critical numbers, we have to be real careful here that we deal with the correct function. So if I want to know when does the particle change direction, or when does its position change direction, you want to think really clearly on this. I'm going to write this up here. I think we'll leave this here. And I'm just going to move over here for part C. You want to think really clearly about this, and you want to say position, and I'm just writing this for notes. This is not part of your answer. You want to think, okay, position changes direction at a relative max or min. And a relative max or min is created by critical numbers. So if I want to take my position function and to figure out where my relative max or min would be, I would take the derivative of my position and I would set that equal to undefined and 0 to find some critical numbers. Well, you guys should know that the derivative of position is velocity. So really this is just asking you to take the velocity and set it equal to 0 and undefined. Let's get some critical numbers and see where this changes direction. So if we go back over and steal our velocity function, we're going to say, okay, the velocity function I'm just going to recopy that here from the problem. The velocity function, this ugly -2 plus the quantity t squared plus 3t to the 6/5 minus t cubed. All right. So the question becomes, when is that undefined and when is that equal to 0? Well, the easiest thing to do here, we could take our we could try to solve that, but that's really messy. We're just going to use our calculator and look for x-intercepts or any place where it's undefined. So we're going to go ahead and use our calculator to solve for when this is equal to 0 or if there's any place where it's undefined. So take advantage of that and we'll just graph that. And so I'm going to go into y equals. Actually, I had this punched in here from before. So there's -2 plus the quantity x squared plus 3x to the 6/5 minus x cubed. And on my window, I'm going to still keep that from 0 to 5 because that's the range of the x values of the domain. And I'm going to go back and make my y minimum a little bit lower. Instead of -1, I'm going to go -5. And let's see what we get. This looks like the function comes through. It looks like between 0 and 1, around 0.5, it comes up and a little after 3. And those are the two zeros, and it's defined everywhere. We don't have any discontinuity here. So I'm going to figure out what those values are. Again, I'll use the calculator just to find my zeros. So I'll use 2, and first curve, or there's my first a value here, and I'll get on the other side of the intercept and back up. And one of my values is 3.318 rounded. So it looks like it is at t is equal to 3.318 rounded. And then if I bring this over, it's around a half, and I'm just going to give you that value here for the sake of time, and that's going to be 0.536. 0.536. So obviously this is the first one, this is the second one in our picture. Those are the two values. So those turn out to be my critical numbers. So if I put these to the side, I've got my two critical numbers, and the question says, when do these two values here change direction? Well, I'm going to actually test my interval here. And so I'm going to take these two values, and I'm going to say, well, at 0 and 5, we have that. And I'm going to put in 0.536 and 3.318. Now, the reason you have to check these is it's possible maybe one of these turned out to be an inflection point where if we were to graph it, instead of being a peak or a valley, it's possible it could have just been a flat spot and you did not change direction. You just continued to increase, or on the way down you created a critical point, but you continued to decrease. So you have to make sure we're looking for these values and we're testing to make sure that this is not what happened. So we're just going to test our intervals to see about increasing and decreasing. So this is our velocity values, and it's telling us about position up top. So I'm just going to pick a number between 0 and 5.6 and see what's going on. But I'm actually just going to use the calculator to test that interval. So if you guys look, if you notice between 0 and 1 here, between 0.5, if you see the function here is below the x-axis, so these are negative numbers right here. So I know what's going on here is negative, therefore I know the function is decreasing. And if you look between 0.5 and 3.3, you can see that the function's positive. So the velocity is positive, therefore the original function's increasing. And then back here one more time, you can see the function's below the x-axis, so the velocity is negative, so this is decreasing. So there you can see with confidence that, sure enough, it does actually change direction at these critical points. So the velocity goes from negative to positive at 0.536, and the derivative velocity goes from positive to negative at 3.18. So we can say, very confidently, the particle changes direction. And we don't need this little sketch here anymore. The particle changes direction at t equals 0.536 because velocity, v of t, goes from negative to positive. And we can say the particle also changes direction at t equals 3.318 because v of t goes from positive to negative. Okay. And you can always word this a little bit better, and if you compare to the official AP answers, sometimes they make them nice and clean. And you could say velocity goes from negative to positive at t equals 0.536, therefore the particle changes direction, or the particle goes from, or the velocity goes from positive to negative at t equals 3.318, therefore the positive particle changes direction. However you want to say that. But that's your justification there, is that the velocity changes sign and goes from, since the velocity changes sign, you know the particle changes direction. All right. Now, part D. Part D says, is the speed of the particle increasing or decreasing at t equals 4? Well, a very important property that you want to have memorized for your calculus and physics career is a property about speed. And here's how it works if you've never seen this before. All right. The rule is speed is increasing given the following. Speed is increasing if the acceleration and the velocity at a particular time have the same sign. So if they're both positive or they're both negative, your speed is increasing. The other rule is, you could probably guess, speed is decreasing if A of t and V of t have opposite signs. And that is a fair enough justification. So let's go ahead and calculate what the velocity and the acceleration is at time equals 4. So we just have to figure out what v of 4 is. So we'll put 4 into the velocity function that we have. So we'll use our calculator for that. And let's see if we can enter that. The velocity function here, we have it written several places. And I'm going to say it's negative 2 plus left parentheses 4 squared, which is 16. And then we're going to add to that 3 times 4 would be 12. Close parentheses, raise that to the 6 divided by 5. And then it's going to be minus 4 cubed. So that would be minus 64. And let's see what we get. Negative 11.476 rounded. Okay, and really all we care about is the sign. So our velocity is negative, so let's check the acceleration. Well, in order to check the acceleration, we'd have to take the derivative of this, because back to here now, sure enough, they do want acceleration, so we have to use our derivative skills to find that. So we have to find v prime of 4, and v prime of 4 is the same as the acceleration at 4. Well, you have a choice here. You could, if you want, by the longhand, you could go ahead and take the derivative of this using your chain rule and power rule. But since it's a calculator question, I'm going to go ahead and just use the calculator's ability, and this makes it a little quicker. So I'm going to go to the math menu, and I'm going to take number 8 here, and I'm going to say it wants me to take the derivative of the actual velocity function, so I'm going to put that in there, which negative 2, again, plus left parentheses, x squared plus 3x, close parentheses, raised to the 6 divided by 5, and minus x cubed. So I'm going to take the derivative, the calculator will take the derivative of the function, and then we're going to evaluate it at 4, so I'm putting 4 in there, and the calculator gives us negative 22.296 rounded. Well, it looks like we have negative velocity, we have negative acceleration, and therefore we can confidently say speed is increasing at t equals 4 because v of 4 and a of 4, the velocity and acceleration of 4, are both negative. If you wanted, you could say they have the same sign. Either way is fine. So let's go back to the top here. A very friendly, straightforward PVA type question. And so it's all going to be focused on this little diagram right here. And so what do? They give you a velocity function, which is very, very common. And they ask you questions about position, questions about acceleration, and questions about speed. And so the first question was a speed question. Did you know that that's the absolute value of velocity? You set it equal to what they asked within the interval and just solve for your values. Calculator question if it's a messy function, or you can do this by hand if it's not so messy or it's a non-calculator question. You just got to make sure you do absolute value correctly. Then part B, find the position of the function over a given interval. You're just doing your fundamental theorem. You're integrating velocity, knowing that gives you position. Just make sure you bring your initial position over, and it was 10 for the problem when we got our final answer, which was right here actually. And then we set it up for just t. Then part C was find the places where the position changes direction. Well, position changes direction at peaks and valleys, we like to say, so you set your derivative of position equal to 0. Well, the derivative of position is velocity, and we have that function. So when is velocity equal to 0 undefined to get our critical numbers? We used our calculator to solve for those values. It was never undefined, but it was 0 twice. I did an interval test to see that sure enough it was changing direction, not just inflection points. And I say the particle changes direction at those two values because my derivative, my velocity, goes from positive to negative, and they require you to state that. Interval test is not enough. And then a final question regarding speed, increasing or decreasing, and it's they're quizzing you to see, do you know this very, very important rule that all AP Physics and Calc students should know regarding speed? Both same sign for acceleration and velocity gives you increasing speed. Opposite signs mean it's decreasing. And we take advantage of our calculator. Again, if it was a more friendly function, we could do all of this without a calculator. It would just have to be a friendly polynomial, probably would work. And there you go. Calc AB 2013, number 2, PVA type question with a calculator. Thanks for watching. See you next time.